Hey guys, welcome to a conversation about security. In the confines of security, the primary tool that we have when we look at from the point of view of CCNA certification is going to be something referred to as an access list. Now, access lists give us a unique ability, the ability to be able to manage the traffic that's actually traveling across our links. So what we need to do is we need to understand exactly what an access list is and how an access list operates. An access list is merely a filter that we're going to be able to apply to an interface based on direction. So when we look at the working definition here, an access list is going to be a tool that we can use to be able to manipulate and identify traffic. An access list is going to consist of a series of permit or deny statements. And in all actuality, it's going to consist possibly of both. So what we need to understand, first of all, is that if we create an access list, there's whatever parameters that we assign that are going to be explicit configs, and then at the very, very bottom, we're going to have what's referred to as the implicit deny. So if we permit a half a dozen different types of traffic, what we have to understand is there's an invisible statement at the end of the access list that's going to say deny everything else. So that's something that we definitely want to make certain that we embrace and understand very early on. Now what we have here is that we can use access lists to identify traffic based on a number of different pieces of information. It can be actually done on information that's contained inside of the IP packet itself. Now after we've identified traffic, what we can do is we can employ an access list to be able to take certain types of actions. We can drop traffic, we can allow traffic, we can redirect traffic. We'll learn later on in our studies that we can use access lists in unison with something called policy-based routing processes, where we can say, oh, if it matches this particular access list, I want to send it this way rather than send it the way the regular IGP routing protocol would send the traffic. So access lists offer us a lot of tools, not just from the point of view of security, but from the ability to be able to have granular control over our traffic. The other thing that I want to note here is that access lists can be used on both routers and on switches. Now, an access list is a pretty interesting tool, and it really does follow a baseline of performance characteristics. So what we see right here is an outline. In this outline, I have highlighted everything that our access list is going to do. And what I want to do is I want to walk through that list in order to be able to look through this process. So when we create an access list, the access list is going to have a series of parameters that are going to be listed in order. And what we're going to do is we're going to say, for instance, sequence 10, 20, 30, and 40 are going to match based on some criteria. Typically, it's going to be based on some aspect of the network address. Now, obviously, there's other things that we can match on. But what we need to realize here is that on a case-by-case basis, each of these lines, let's say this was sequence 10, sequence 20, sequence 30, what we're going to find here is that we're going to either permit or allow traffic based on how we've done the configuration. If we're going to deny traffic, that traffic is going to be automatically discarded. If we're going to allow the traffic, then the traffic is going to be permitted. And we'll go ahead and execute each of these lists all the way down till we reach this notion of the implicit deny. So if I have 3 permits and nothing else in my list, what I have to recognize right out of the gate is that my access list is going to automatically deny any traffic that did not specifically match any of my previous configurational values. And the other thing that we need to understand is this is processed in a top-down order. And what we're going to find here is the first match is going to execute either the permit or the deny, and it's going to stop any other matching. So if something matches access list, the access list that I configure sequence 10, it's going to permit the traffic, and then it's going to just simply stop processing the access list. So the moment that I get a match, I want to stop doing any type of parsing against this list. The other thing that we're going to need to understand here is that based on the fact that it's processed in a top-down fashion, the system now in modern iOSs will actually restructure the access list such that the more specific entries are going to be near the top of the list and the less specific entries are going to be at the bottom. It used to be back in my day when I was coming up, you actually had to remember that process and make certain that you configured the more specific details at the beginning of the list. But like I said, iOS has since been configured to enable the system to overcome any shortfalls that we may have configured or set up by accident. Now, when we look at access lists, we've been talking about network masks. So for instance, I've had a network of 192.168.12.0/24. So that's 255.255.255.0. Now what we need to understand here in the context of access lists is the fact that we don't use network masks. We use something called a wildcard mask, or probably more accurately referred to as an inverse mask. Now I like this term because inverse mask implies exactly what's happening. What we're going to realize is that if in an actual network mask, if I have 1.0 all the way out to my 4 octets, what this means, specifically, if this is a mask, these ones are going to be values that I can't manipulate. We already talked about in the confines of IP addressing. Why I like the term inverse mask rather than wildcard masks is the logic changes. So the only thing that happens is zeros mean that it has to stay the way it is. Ones mean it can be anything in the arrangement. So when we start looking at this, what ends up happening here is 0 means that it has to match. 1 means ignore it, which means I don't care what the value is. Now the rationale behind this is that it gives me the capability of constructing some pretty sophisticated configurational constraints. So now I have the capability of being able to match on even and odd. I have the ability to be able to match in groups with regard to the first 15 addresses or the first 15 sequences. So it's going to give me the capability of being able to do quite a bit of manipulation. And what it's going to set up here is that based on the fact that we're using these ones now, it's saying anything from here over doesn't matter. So ignore the 1, 2, 3, 4, 5, 6 bits, but the zeros have to match, which means the 128s must have a 1 filled in it and the or match here, so it has to be 0 in this instance. If it was actually 1s, then they would have to actually match. But the idea is that this gives us the capability of being very, very granular with regard to how things are interconnected and how things actually operate in our infrastructure. Now when we do our masking, like I said specifically, I want you to think of access lists as filters. Because what I get is the capability, I can actually filter for specific subnets. So for instance, if I wanted to filter the range of addresses from 170.30.16.0 all the way up to 172.30.31.0, I had the capability of saying, well, in this scenario, these values are identical. So I want those to match. So what I do is I would come in here and use zeros, saying they have to match. So it would be 0, 0. Now what I want to realize here is if I take 31 and subtract 15 from it, that's going to give me a value of 15. So what I do is I take this 15 and I can use it to here with my last value being 255.255, which means I don't really care what's in this field. But what I'm going to do is I'm going to count from 16 15 times. So it's going to be 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So in other words, what I've done is I've actually done my range all the way through my configs. So this gives me the capability of saying I wanted to be able to manipulate traffic for specific networks. So the first one counts, so it's going to be 16, 17, 18, 19. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you can see how the counting goes through. Now this gives me the capability of picking the first 15 out of a range, starting with 0 obviously. So let's take a look at some of the other things that we can actually do with an access list. An access gives me the capability of doing things like abbreviations. So what I can do is I can say, rather than looking at a group, I could say I want to match on a specific address. So if I wanted to match on 172, 30, 16, 29 specifically. So I only want to match on that one address. All I would have to do is use a mask of all zeros. So in order to be able to do that, that inverse mask, or that wildcard mask, is going to say these values cannot change. So that's the specific value that I'm going to be matching on. Now when we start looking at this, we can actually abbreviate this wildcard mask using the IP address preceded by the keyword host. So rather than saying 172.30.16.29 and specify a mask of 0, 0, 0, 0, saying that all of these values must match, what I could do is I can write my access list that says match on host 172.30.16.29. And that's going to be the exact same output. And that's going to be this idea of mask abbreviations. Now also when we go through here, we can understand, we can specify no value, nothing specifically, all zeros, and we can use, by using the 255s, we're saying ones, so that means we're going to ignore all address bits. And we're going to specify this saying, this is saying match on anything. So what do? We can actually abbreviate matching on anything using the keyword any. So let's take a look at what's happening here. In the confines of our system, we need to recognize that we have access lists, but specifically we have different types of access lists. We have standard access lists, we have extended access lists, we have the idea of named access lists. So let's go through this listing of configuration. So a standard access list matches specifically on a source address. I always remember this by the S. So standard matches on source. Then what we end up happening here is that what we're going to do is based on whether or not we permit or deny the traffic. Never lose sight of the implicit deny at the end of an ACL. An extended access list. Extended tells me that I have the capability of matching both on the source and the destination IP addresses. And generally what we're going to find is we're going to use permits or denies, and we also have the capability of matching on specific protocols. Remember we talked about port 23, we talked about port 21, we talked about port 53, we talked about port 80, we talked about port 443. These are going to be values that we can actually use an access list in the extended form to match on. So not only can we permit or deny on specific information associated with a source and destination IP address, we can also do it based on port numbers, specific for protocols. And then what we also need is a regular, whether we're using standard or extended, we have this idea of having numbered access lists or named access lists. Now let me warn you, when I was coming up, one of the big problems was that if you had an access list and you used a numbered access list, you could not edit it. So if you made a mistake and you put something out of the wrong order, and remember back when I started, iOS wasn't that intelligent with regard to be able to make decisions about access lists. So it didn't reorganize them for you. So if you screwed the pooch, you had to go back through and you had to do your configurations on your own. So you deleted the entire access list. Hopefully you remembered to paste it into something like Notebook or Notepad, excuse me, so that you could actually manipulate it and paste it back without having to recreate it from scratch. But there's been times, I have to admit, that I forgot to do that. And I'm not the only one. I'm probably the only one that will admit to it, but I know I'm not the only one that's actually done it. So what ended up happening was Cisco made a change. Cisco said that, well, if you create an access list using the numbered format, what you can do is you can actually reconfigure it as if it was a named list using the number for the name, and that's going to give you the capability of being able to edit your access list. Now the drawback here is now what you do is you cannot create named access lists using just numbers, because every numbered access list has a reserved title inside the confines of the named access list. And we'll look at exactly what's involved in that process very shortly. But bear in mind, access lists are the primary go-to tool that we're going to use to do a lot of our control and implementation. So when I look at this, the question is how do I know one access list from another? Well, if I'm using a numbered access list, that means I'm going to be using it in the range of 1 to 99 and from 1300 to 1999. These are referred to as our expanded range. So originally we only had the capability of having 99 access lists. Then what they realized is they needed to expand the range in the numbered to give us more. I will tell you, I have clients that have access lists that are in the 1,000. So 1,000 individual entries on the access list. The majority of them are service providers. Some of them are casinos. But the main thing that you need to understand here is that they have some pretty honking big access lists. And what would end up happening if we only had 99, it would severely hamper our ability to be able to do some of the things that they implement. We also have the idea of numbered extended accessors. Because remember, on standard we can filter on source. On extended, we can filter on source, we can filter on destination, we can filter on port. Now the way I know it's a numbered access list that's in the extended range is the number range itself. 100 to 199 used to be the range, but again they expanded it to support 2,000 to 2,699. And obviously the easiest one to recognize is a name access list, because if it has a name and not a number, it's obviously going to be a named access list. Now when we look at this again, it's all dependent upon how we have these deployed in our infrastructure with regard to what it is they're actually going to be doing for us. So if I wanted to go through here, I can go in and I can test an IP packet against a numbered standard access list. And how can I do that? Well, I can specify how I'm going to look at it. Remember, our standard access lists filter on source. So we're looking at the source IP address or the source network. So when we go through here, keep in mind what we're going to do is we're going to take the IP packet header. We're going to look inside the IP packet header and we're going to look at the source address. Based on our access list configuration, we're either going to make a decision to permit or to not deny that traffic. Again, never losing sight of the fact if we permit, we also still have that at the bottom of the list, the idea of the implicit deny. Never lose sight of that fact. In fact, I tell most students to go ahead and make a deny all statement at the end of the access list for the purposes of being able to troubleshoot your configurations. Because what you're going to find here is when we take a look at these access lists, every line that matches a packet is going to get an incrementer against it. It's going to go up by counts based on the number of packets that it matches. The implicit deny can't be seen, therefore we can't see what's being matched against it. If we go so far as to create an actual explicit deny where it says, I deny all, then what's going to end up happening is that all those denies will actually be hit. So if you go through and you start doing your testing and something's disappeared and you start looking at your access list, if you have that explicit deny in there, you're going to see the fact that it's incrementing, it's counting. So that means that it's actually blocking traffic. So, looking at how the systems are all deployed, like I said, when we set these up, how do we implement it? Well, again, it's all about syntax in the context of iOS. To create a numbered access list, whether I'm using a standard access list or whether I'm using an expanded access list, well, this is a standard normal and standard expanded. What I need to realize is I'm going to use the access-list, the number, and permit or deny, and then specify whichever prefix I'm going to use, bearing in mind that I'm going to use the inverse mask. If I want to see these, all I have to do is execute show access list. And one of the things that I really wish that they had in here in this illustration is that every time it has been matched, I'm going to have a field over here that's going to tell me in parentheses how many times it actually met or satisfied its own search criteria. Now the other part of this is if I want to get rid of this access list. To delete it, I just merely use the no version of the command. So no access list, that's going to get it out of my way. If I type a show access list, what's going to happen? It's not going to show me any type of information. So using the no access list and the number is going to remove the entire ACL from my system. Now the next part of this is the fact that when we start looking at how we're going to deploy these things, again, I want to do this on the equipment. We're going to create a group of access lists and see if we can't do some manipulations to prevent traffic, because there's some things that we haven't covered here, specifically the fact that our access lists are going to be directional in nature. But what we want to do right before that is let's dive in and take a look at some of the actual deployments in the next lesson with regard to how our access lists are going to be operating and some of the ways that we can use them before we dive into the lab. I'll see you guys in that lesson. Bye-bye.